So the typical workflow in here is we import or load the file. There's a couple of ways how we can do it. So I can just select this file that you had emailed us in here, and I can just drag it and drop it in here, and it'll ask you, do you want to open or import it? I can pick open. And now when you open it, it'll ask you what units was this file designed in. Was it in millimeters or inches or whatever the CAD model units is? You can select those relevant units for it. Would you know if it was in millimeters or inches?
Try millimeters.
Millimeters, okay. I'm going to accept that. And it's translating the file, reading it. And once the part is loaded, you will see that up here on the viewport. So if your part has a lot of triangles or meshes on it, the load time could take anywhere from a few seconds to a couple of minutes. So as you can see here, it's in the process of loading it. And you can see now it shows up in all the 4 viewports. I can just maximize it to 1. I can click on display in a shaded view, and I can also go into this display tab in here, and I can turn the display off the what we call it as we have a display tab where we can turn off the display of the mesh wires. So I can go into the display tab and turn off the wires so we can actually look at the model. Okay?
Yep.
All right. Now, the part is somewhere out in space, so we'll look at how we want to align it, orient it. So the typical workflow is once you bring in a part, you can go into the machine setup on the Program tab in the RhinoCAM's machining browser. So the RhinoCAM's interface appears directly in Rhino. As you go up to the RhinoCAM menu, you'll see that the mill is automatically selected. So it's a fully integrated CAM plugin for Rhino. So the typical workflow is you go down to the Program tab, you select Machine, and you define the machining process here. So you would select the machine number of axes is 5. You pick the configuration as head because the machine that you have, the Thermwood, uses the rotation is on both the heads. You can specify the primary axis, the secondary axis, and this is where we talk about the gauge length. So this gauge length is the distance from the pivot point to the spindle face. And then you also specify the tool length as you define your tool. Since the tool lengths could vary for each tool, but the gauge length is going to be the same for a given head. Am I making sense here?
Yep.
Okay, so you would put in this.
Yeah, and I have that.
Be like, okay, do you know what that would be?
I have that gauge length. Yeah. It's in inches.
Mm-hmm.
It's 10.4983.
10.4983.
So take away one of those 4s. Yeah.
Okay, got it.
Right
now this is excluding the tool distance from the tip of the tool to the spindle face. Is that correct? So we will add the tool length to it. Okay, perfect. So when you set this to a non-zero value, we do that automatically. Now, as far as the post processor goes, we've developed posts for a wide range of machine tools, and we also have several different variations for Thermwood machines as well. So you can see that I have a bunch of different posts in here. So if I grab one of these posts, let's say I want to grab one of these in here, I'm going to go ahead and grab this. If I do an edit, this will let us modify or customize the post processors in here. And you can see here we use either the G47 or G52. So there's different options where we can put in the post processor depending on how it's being handled on each of the machine tools. So some Thermwood machines, the controllers, they have what's called the G48S1. We can put that in here. So in this case, we're putting in the G47 as you see right there, right?
Yep.
So depending on what your controller supports, we can do that and also specify the extension as .NC or .CNC or whatever is the preferred extension, we can specify it in here. So once you have the machine tool defined, you post selected, the next step is you go through the process of defining the orientation. So as you take a look at it, the part looking down from the top view, does the part look in the right orientation? Or as you look at it from the front, does it look as how you want it to be machined? So make sure that the part is oriented and placed correctly on the machine tool. So that would be the next step is the orientation. You can orient the part if you need to. And then you build your stock material. So when you go to stock and box stock, this actually computes a bounding extents and gives you the length, width, and the height.
Is that in millimeters or inches?
Right now it's in millimeters.
Okay.
Do these numbers look correct?
Right. Yep.
Okay. Would you like to work in millimeters or would you like to work in inches?
Inches is preferred, but
Okay, so the process to switch is pretty straightforward. So just right-click on the unit, millimeter units down
yep,
in the status bar, go to unit settings, and then you can change from millimeters to inches, and then you accept that. It'll ask you, would you like to scale the part, and you select yes. So in this particular step, the model unit was switched, and then you can go back and check the extension here. Now you can see that the length, the distance on the x-axis is about 11 inches, the width on the y is 4, and then the height or the thickness is about 15 inches.
that's correct.
All right. So we could go ahead and define the stock in here, or we can orient the part and then create the stock. So we can do align set wall. We could say we want to put the part to the lowest Z and in the center. If you want to do it, put it in the lowest Z and center. You can place it right there. So now the part is right on the origin as you see it. Now, would you like to zero it out to the top or to the bottom?
We can zero out. That's fine where it's at. That works.
Okay. And let's go ahead and create a stock in here. And I'm going to hit copy model box. It gives me the length, width, and height. I'm going to make the stock slightly larger. So instead of 11 inches, I'm going to put in 12. I can change this to 15. And then the height is 15.47. I can change it to round it off to 16. Okay?
Yep.
And the next step, we want to align it. We want to align the stock to the part. So what we would want to do next is basically go through the process of align stock. We want to put it to the bottom, and then the center in X and Y. So as you take a look at the stock and the part, if you take a look at it from the front view, you'll notice that the bottom face of the stock is flushed with the bottom of the part. And if you look at it from the top view, you will notice that there's material left on all the sides. So now when you save this file in Rhinoceros, it will ask you where would you want to save it. You pick save. All of the information that you put in so far gets saved with the file. So one of the things you could look at is the number of meshes or triangles you have on this model. For some of the machining applications in here, you may not necessarily have to have a model that has so many millions of triangles, for example, in here. So one of the things you could do is if you go into Rhino and type in the word what, it'll tell you how many meshes are there. So you can see it's little over under 3 million. Is that right?
Yep.
Okay. So there's a couple of ways. What you can do is to make it easier for machining, you can reduce the mesh in Rhino, or we also have an add-on module called Mesh, which gives you additional controls for mesh processing in here. So we have this mesh module where I can go in to do a mesh reduction in here. I can select this mesh, and I can say I want to reduce it down by, let's say, 70%. And then I can pick reduce. This will actually reduce the number of triangles to a third of its actual size. So the mesh module will allow you to do like mesh processing, mesh editing. You can also do mesh offsetting. So there's a lot of mesh tools that are available to you. So if you don't, need such a high, fine refined mesh, you really don't have to have it. So it'll also improve the processing of your toolpath, which would make it a lot faster as well.
Yeah, it's just a balance between reducing the mesh and lowering the surface finish.
Well, the surface finish, if you look at the details after it's reducing the mesh, if it looks good, then what you see is what you get when you actually program it or machine it.
Yeah.
So I'm currently in the process of, as you can see here, is doing a mesh reduction in here. So once the process is complete, we could go back into our mill module to program the toolpath. So now we can see that the mesh reduction is completed, and we can take a look at the count on how many triangles we have on it. So you can see now it's down to less than 1 million triangles, right? Is it 859,000 triangles? So now you can see the details are still there, right? It's not like we've lost it. So you can see the resolution is still there. It's pretty good. Okay, so let's go back into our mill module, and then we can start processing our toolpaths. Now, typically, in a part like this, you would want to do like an indexed machining, like machining from different orientations. Is that right?
Yeah.
Okay.
Yeah.
The first step is
mostly 3+2, 5-axis indexing.
Okay. So the prior way we do it is go ahead and create some tools. or we can load a library of tools. We support different tool types like ball mills, flat mills, corner radius tools for engraving, chamfer, taper, thread mill, flat mills. We can also use dovetail cutters, fillet mills, lollipop cutters. Like these can be used for like 2D operations. And you have drill, center drill, reamer, tap bore, and reverse bore. You can define tools under each tool type, also set the feeds and speeds, and save them all to a library. Now I could use these tools in here or load one from a library in here. I can go find a tool library that may have saved somewhere in here. So I'm going to go in and go into one of my folders in here, and I'm going to go ahead and grab a tool library in here. So just give me a moment. Let me go look for a tool library file in here.
Well, I can give you the 3/4-inch ball mill that we're going to use for most of it.
Okay, is that what you're going to be using for most part? Okay, so I can just go ahead and drop a 3/4-inch ball mill in here. So I'm going to define a tool specified as ball mill 3/4-inch. Now, would you be using the same for both roughing and finishing, or would you be using different tools?
There'll be a 1/2-inch ball for finishing. So this will be the 3/4 for roughing, and then a 1/2-inch for finishing.
And what would be a typical tool length, like 8 inches or 7 inches or long?
It's only 4.074.
Okay, you got it all precise. Okay, perfect. So I'm just going to put in tool length as 4.074. Leave the tool number as 1. In the feeds and speeds, I can go ahead and establish feeds and speeds based on the material. I can also say what is the maximum RPM your machine can handle and the cut feed rate, and I can set these up here. So, for example, I can put in, this is 3/4 of an inch. It gives you a recommendation of the spindle speed and cut feed rate based on the material and the tool material, and I can change the spindle RPM. I could say I want to run it at 15,000 RPM. It'll recompute your feed rate for like 300 inches per minute. I can go ahead and accept that. I'm sorry, can you repeat that again?
It's a 4-flute end mill, so you actually get...
You can go with a much higher feed rate. Yes, I can see that. Okay. So I can go back and change the number of flutes to 4, and I can go back to feeds and speeds, select this here, and now you'll notice that since the number of flutes is higher, you can cut even at a higher feed rate, right?
Yeah, good.
Yeah. So what would your feed rates typically be?
On these thermwoods, they actually just run them at 1,200 because the acceleration and deceleration is so slow that it doesn't matter. So you can run it at 1,200.
Okay, so I'm going to put in 1,200 here, and I'll accept that and save the edits to the tool. So this would be a roughing process with a 3/4-inch ball mill. So now what I'm going to do here is go ahead and select a 3D roughing process so we can rough it down in levels, and we'll start from the top and work its way down towards the bottom in the Z, right? So the process would be to rough it out from different orientations, like you said, 3+2 is what we do, machine it from different planes or different orientations. So the process is, go ahead and select 3-axis machining, and then first do the roughing from the top down. So you can go to 3-axis, pick roughing, and then over here you can select the tool. Your feeds and speeds are automatically loaded from your tool. Your clearance is set to automatic based on the orientation of your coordinate system in here. It's parallel to the XY plane for machining, and you can choose whether you want to do linear cuts or you can do, what type of cut pattern. You can pick linear. If you just wanted to go back and forth, you can give it a step over, like say 50% of the tool diameter, right? So I could put it in as 50%, and I could just run it, specify, give it a tolerance in here. Since it's a mesh model, the model will be fine. I can say leave about 0.2 inches of stock after the roughing process. Then I can go down to cut levels and say how much of material I would like to take down per pass. I could do like 100% or 50% or whatever that is. In the bottom of cut, I could say how far down I wanted to cut. So I can even pick a point in here. I can say snap to a vertex and say this is the point I want to go to. So the cutter will not go below the point what you pick in here from each of the orientations. So you just snap to a vertex, and it'll actually transfer that information over to RhinoCam. So when you pick a point, it actually obtains that information from your model, the Z height. So I'm just picking a point in here, as you can see right there. That's how far down I want to cut from the top, right? Just as an example here. So that's 11. I could say keep it to just 12 inches, right?
Yep.
Okay, and then you can specify your engage and retracts. If you just want to do a vertical approach, you could do that, and then any advanced parameters you could set. And then now we can generate this toolpath in here. So in this process, it's going to create a roughing in levels toolpath, it does Z-level roughing or roughing in layers, and it'll create these, you know, linear passes, or you could call it, lace cuts, just cutting it back and forth following the 3D model. So now while it's roughing from one of these orientations in here, you can go ahead and process some additional operations in here. Like, for example, you could do go back and create a new orientation. And in this particular case, I could say I want to change the orientation from the top to one of the sides in here. So maybe look at it from the right side. So I can rotate the coordinate system. I'm going to rotate 90 degrees on the y-axis. I can also rotate it if I need to on the z-axis if you need to, but it's not necessary. So now the z-axis is normal to this face. And I could repeat the same roughing operation in here, or I could use a re-roughing operation, which actually will take into account the stock that's being left from the previous orientation. So that's how you can create the 3+2, or we call it the, locking the tool axis to different planes or orientation. So now you can see that the roughing operation is completed right there. It's taking account of the stock that you define and creating the roughing in levels. Now let's go ahead and run a verification for it here. So you can see that with the ball mill, it's cutting it, it's roughing down in levels.
Yep.
So I just chose a linear pattern. We have other types of cut patterns in here as well. We could do offset patterns. So you can see it's going down in levels or layers. Now, if you do notice a hold a collision, it's going to mark those areas during the simulation. So if you're cutting too deep with the tool based on the tool end that you put in and the holder diameter that we put in here, if there's going to be a collision, it'll mark those areas. And at any point of time, you can pick the pause button and then pick simulate to end, and that'll run the simulation all the way through to the end. Any questions so far?
Nope.
Okay. So looks like that will be the final cut right there. And I'm going to do a pause, and then I can do simulate to end, or just let it run through the simulation. Okay. So there's the roughing operation in here. And the next step is, we've already oriented the coordinate system, and I'm going to create rather than doing a roughing, I'm going to do a re-roughing, so which will take into account the stock that was left from the previous step. So use the same cutter, same feet and speed settings. The clearance is set. You can see now the clearance plane is parallel to the rotated XY plane. And then you can set your parameters in here. So use the same settings for the stock to leave. I can leave 200 thousandths. I just set my tolerance, the in tol and the out tol. Use the same linear cutting pattern in here. Now I can run the cutter either parallel to X or parallel to Y. So I'm just going to leave it as parallel to X, or if you want to run it parallel to Y, you can run it parallel to Y as well. So you can change the angle of cut. So if you want to go parallel to Y, you put in the angle as 90 degrees. So it'll go back and forth parallel to Y. If you want to leave it as 0, go parallel to X. And the same settings you can use for, specifying your step overs in here. And now let's go into cut levels. This is where we want to specify how far we want to go back to. So you can see that the plane that you're putting is also parallel to this axis in here, right? So I could say I want to go past maybe the midpoint here. I can even enter in a value in here, or I can even snap to the cell in the grid. I can say snap to my grid, and I can just say go ahead and snap to the grid right there. So it looks like I just clicked on our website in here. I'm just going to go pick this point right there. So you can say I can specify the value, or I can say minus 0.25 or minus 0.5. Give it a little bit of overlap in there, right? And then I can basically do a vertical approach for entry and exit, save it, or I can do a generate on it. So right-click, regenerate. So in this process, it's computing the toolpath, and again, we are using the multi-threading manager. So as this is being computed, you can create additional operations. Now what I'm going to do is take the setup in here, do a copy and a paste. So the setup will be mirrored or copied completely. You get a copy of the setup, and you can mirror it now to the other side. So by just double-clicking on it, edit it, and you can change it to the other side by saying I wanted to rotate it about the y-axis by 180 degrees. So you want to machine it from the other side, right?
Yep.
We can also do the back of it, and also from the front of it, we can set it up to different orientations. See how much of material is being left in the roughing process from after the re-roughing is completed. So it's very intuitive powerful and easy to use as you're seeing it right here. Now, one of the things I would also have to do is go back into this machine setup, and I can set up the limits of the primary axis. So if you have a 0 to 360 limit on the C axis, you can specify that. And the secondary axis typically is like minus to plus 110 or 120, depending on how far it can travel, right?
Yeah, it's 135.
Okay, so plus or minus 135, I'm going to put it in here.
And then the primary axis is 0 to 360.
Okay, I'll put that in here. So now you can see that the roughing operation, the re-roughing is done. And as you can tell here, it's not cutting air because it knows that the material is already cleared out.
And is it going underneath the part?
Wherever the cutter can get to, it would. From looking through that.
How do you limit it? Yeah, how would we limit it to not cut the bottom of the part so it doesn't fall off?
So we can put a region around it in here to contain the toolpath. So we can specify, you can see now it's going all the way down to where the stock is. Now typically you may want to put it on like a raised pedestal or like a, you can model something so that way there's enough room for the head to go down, but then at the base of the stock you may have like a little cylinder and then the stock extends and sits on top of it. That's how you may want to mount it, right? But if you want it to not cut all the way to the bottom, you can put a bounding rectangle like a region, simple as a rectangle to contain your toolpaths.
Yeah.
And I can show that to you here. So I'm going to run through the simulation here. So right now you notice that it's going all the way through the bottom, right? So if you want to limit the toolpath, I can go over here and I can create a machining region. So for example, I could say a region could be as simple as just a rectangle in here. I could say this is how far I want it to go and cut. So I can pick two corners to define a rectangle, and the rectangle can be used as your containment. So I can pick
and then can you
in the rough operation.
Can you dimension that now? To the stock bottom? Yeah.
Yeah, you can specify it and you can do it in Rhino. Yes, that's all in Rhino. So for example, if you take a look at the stock in here, that's how far down it's going, right? So if you measure this point, analyze a point in here, it tells you what this coordinate is, right? So you're about 2 inches off the, base. So now I can just use this as my boundary in here. I just put a boundary that's larger than the part. I could even make it smaller. So Rhino has tools to adjust these settings in here.
Yep, and then if you wanted to set that like a 1/4 inch off the bottom of your stock.
Yeah, so the bottom of the stock is 0, right? So I can take this down and move it down by minus 1.75. If you do this here, the tip of the tool is going to stay up to this. So I would say add the tool tip also to it. So I would move it up by 0.375 from here.
Yeah.
Okay? So now I can select this in here, and I can pick that as my boundary in here. So that's how easy it is to create these boundaries in here. Now I can go back into this machining operation. I can edit this out, and then I can select a boundary. I can pick this, and then go back and regenerate the toolpath for it.
Cool.
So now the toolpath gets contained to this area, and it's going to basically limit the toolpath to the boundary. Any questions while the toolpath is being computed?
No.
Okay, so as you can see, the re-roughing operation is taking into account the part and the stock that's being left from the previous steps. So it's not just computing the toolpath based on the initial stock. So if you're doing it based on the initial stock, you'd be probably cutting a lot of air because those materials have been removed, cleared out in the previous process. So this is a very efficient process. So you can eliminate the toolpaths. Now you can see that the cutter is automatically stopping right there.
Perfect.
Okay. So now I'm going to go ahead and run a simulation so you can see it. So that's doing your cut material verification.
Yep, looks good.
I'm going to do a pause, pick simulate to end.
You want to hide the toolpath?
Absolutely. So now you can see that there's a holder collision you can see with the stock right there.
Yeah.
So those red are showing holder collisions. Now I can repeat the same for this side in here. So the holder collisions are also marked, and you can also see them being represented on your toolpath in here. So those are the lines where you can see the holder collisions. Okay, now let's repeat the same for the other side in here. So I'm just going to go back and reselect this region in here. So basically we copy the settings over from the previous operation. The same cut levels are being set. Pass on the side. And then I'm going to right click and regenerate this toolpath in here as well. Any questions, sir?
Nope.
Okay. Now the next thing we're going to do is take a look at the posted output in here. And we'll also do some pre-finishing operations.
Okay. Yeah, let's try and just put a finishing off with the same 3/4 inch ball.
Okay.
And then we'll look at the output from the post processor.
Okay. So the re-roughing is being computed, so I can go back and do some pre-finishing operations in here. So I can start with the same side, or, yeah, okay, so looks like this one just got done here, and we are running a verification for this as well.
Yep, looks good. Other than hopefully fine.
Okay, yep. Now let's go back and do a pre-finishing in here. So with the same orientation, I can go back and do a pre-finishing, or we can rotate it back to the top in here, put it back to the world coordinate system, and then you can start over by doing pre-finishing. So there's different ways you could do it. One of the popular operations uses like a parallel finishing in here, where you can specify the tool. I can go ahead and use a 1/2 inch from a 3/4, right? Is that what you prefer?
I would just use that tool for now. That's fine.
Use the same one? Okay, we could do that. Okay. Yeah. And then we'll specify feet and speeds, clearance. In the cutting parameters, you can set the tolerance for finishing in here. I could put that in there. The angle of cut, you can say 0, 90, 45. I'll just go at 45 degrees. You can say how fine you want the cutter to step. You could do like a 45 or 10% step over, really fine. And I can also put in a Z containment in here. So I can say I only want to go down up to 16 or 12, right? So that's how far you want it to cut, right? You can specify that. And also you can control your entry and exit. You can also do clearance and say skim when you transfer between areas in here, like 50,000 to 25,000 skimming over.
What is skim, sorry?
So rather than retracting all the way to clearance between transfers, just skim above the previous cut.
Yep.
So now I'm going to run this toolpath in here. Okay, so as you can see here, the roughing just got done right there. The pre-finishing toolpath is generated. So you can see these transfers as I was talking about skimming rather than retracting all the way up to the clearance plane. Also the region, I could create different types of regions in here to see how I want the cutter to be limited to. So right now it's just using a boundary in here. I didn't pick a region. It's just automatically looking at the model, and then since I said do not cut below a certain Z, it's just extending to the plane and face. Okay?
Yep.
So there's our roughing process and pre-finishing process. So we can do multiple levels of pre-finishing. We can also do it from different orientations at different sides. So similar to what we did on the other one, right? I can go back in here, make a copy of the setup in here, paste it down, and then I can apply the same orientation in here, put it to 90 degrees on the Y, and basically take this operation in here. I can use the same containment boundary. Then I can say Z containment, go to minus 0.25. And then generate that pass. I can go generate it.
Now, does that parallel finishing do like the re-roughing does, where it monitors like what stock has already been removed?
Parallel finishing is actually a finishing operation, so it actually does a finishing based on the part itself.
Okay.
So it doesn't take into account the stock.
Already completed.
The stock from it looks at the part surface and creates a toolpath. So it assumes that the operation is already pre-finished, re-roughed out. So you can see now it's doing a finishing. We're just going down from one of the sides, right? It's cutting at an angle of 45 degrees.
Yeah.
So you see the nice finishing cuts right there. So I just chose it to go, 45. I could have just gone at 0, which would have been parallel to the rotated X coordinate axis. Do you have any questions so far?
Nope.
Okay.
But so there's not a way, because it's going to go and redo the head portion that we already did on the first.
Yes, it would. So we would need to go back and modify the region to put it into a smaller area.
Do it by containment.
Right.
Yeah.
Mm-hmm. You just draw a containment. You can use different ways. You can contain it in Rhino, and you can limit the toolpaths.
That's fine.
So any closed curve can be selected as a containment boundary.
Yeah.
Okay, so I'm going to go ahead and just do a pause on the simulation in here, as you've seen the process in here. So I'm going to go back to the Program tab. So now we can consider this as partially complete. Let's take a look at the time for machining information. It gives you the estimated time for each and every setup in here. As you see it right there, based on the parameters, the features that we put in. And then finally, we want to send this out to the machine. We right-click and do a post all. And I'm just going to put it right on my desktop right here. And the posted code should show up in just a moment. Okay, there it is. You can see that the B0, C0 is the primary one. Then we can search and do a next search for the next B value right there.
Yeah, I see that.
I say C180, B minus 90. And before we rotate the head, we can move it to a safe spot so the head rotation can be performed. So that's something you can define. And so by default, it's set to 0, but this is something you can define it over here. So the stock is about 16 inches. I could say if I have a Z travel, enough travel available, I could say I want to move it up to, let's say, 18 inches up in a Z. So I'm going, and then X and Y would be 0. So when I repost this out, you will now notice that before each rotation is performed, it's going to move the head to that specific position and perform the rotation for you.
Correct. I'm opening up one of our G codes that we've run.
Yep. So we can tailor or modify the G code to whatever your controller or machine expects. We can certainly do that. That should not be a problem. And we can also customize the post, like I said. So we have several customers who are using our, or CAM products with a thermoid machine. So this is not something new to us. So we have customers who have been using it.
Okay. I would like to be able to try running this G code on our machine just to see what it looks like. Is there a way you can post out this little bit of code that we've done today, just so I can watch the machine run and look at the offsets and see what it looks like?
Yes. So what I would have to do is get permission from my manager, and for me to provide you a sample code, I can certainly do that. So there's certain things you need to also make sure is if you're if you need to set up the any of the parameters like on your controller, like these are like presets like G804 and G09 F9. So these are all specific to thermal.
I'll send you my header file that you can look at.
Okay.
For kind of what I have in there as far as it is now. Because like the tangency factor, like the machine tolerance, the tangency factor and stuff like that.
Yeah, you can email that information to us, and I can certainly take a look at it.
Okay.
And I will be able to.
If this pretty much will run the machine, then we kind of need to get rocking and rolling, because I think this is kind of a place.
Yeah, so as you can see here, if I go into one of the sites, let's look at this parameter in here. So if you take a look at the first motion in here, the tool motion, so that's your coordinate system in the rotated plane. So if I take this tool path motion in here, and let me just, output it here as just as a curve. So if I analyze this point, that's the point in the world coordinates, X, Y, and Z, right? So if I go ahead and take a look at the re-roughing operation, which is the setup number 2, if you notice the X value is not 6.25, it is 20.822, which is basically it's factoring in your gauge length. If you do the math here, the 20.8223 minus 6.25 gives you the total gauge length.
Yes. Yeah, it should. Plus the tool length too. Plus tool length.
Yeah, plus tool length. Yeah, if you can, it's over. It's about 14 something, right? And also the Z value would drop by the same negative amount, because in order for the pivot point to be, in order for the tooltip to be over here, the pivot point needs to be over here.
Yeah.
Right? So that's how we automatically compensate for that. Yeah, so if you can send me a sample code, you could email it, and then I can certainly take a look at it.
Yeah, that would be great. And if we can get this machine kind of running under your code, we'll look at getting either the indexing or maybe look at full 5-axis.
Okay. Yeah, so our simultaneous 5-axis, you can use this STL model as your gouge check surface to check for gouge against, but you need to have a surface that you need to model so you can have the tool remain normal to that surface that you're trying to machine it from.
So can you do like an offset surface for the full 5-axis?
You can model something, that could be slightly positioned inside this model itself. So you can have a surface drawn, and you can use that. So for example, if I take a look at it from the side view here, so I can model something in Rhino. This is maybe a surface that's going underneath it, and then use it as an extrusion, and then use that surface to drive the tool path.
Okay.
So the tool will remain normal to the drive surface. The drive surface has to be a NURB surface It can be a STL file or a mesh geometry, a drive surface. It has to be a normal, you know, uh, from so it has to be a NURB surface.
Okay. Well, let's see if we can get indexing working, and then if we need to upgrade and play with full 5-axis, we'll do that then.
Okay, that sounds good.
Okay. I'll send. Do you want me to send the G-code file to support at Texas?
Yes, that would work. So if you could email it to us, I can certainly take a look at it for you.
Yogi, and then if you can, hopefully you can send that file back to us.
I would. I can do a part of it, maybe like one top and one of the sides, if that would be okay.
Oh, like the first setup and the second setup?
Yeah, maybe in the roughing from the two setups, or maybe a roughing from the first setup and maybe finishing from one of the side setups. So, yeah, I could do a roughing.
I just want to see the pivot distance work. And
right.
See
so
how
the gauge length work, you need one of the side setups in there. So I can do roughing from the first setup and then roughing from the second setup. So that should give you what you need.
Yeah, that should work.
Okay.
If you could,
the first two setups.
Yeah, if you could do setup the second roughing, the setup 3, just so I can see it bounce from side to side. I don't need any of the finishing paths.
Okay. All right. I will.
Do 1 through.
Yeah, I will talk to my supervisor and get approval so I could send it out to you.
Yeah.
And then if you can email me a sample code, I can take a look and make sure that the output what we are generating from RhinoCam is similar to what your machine is expecting. So if there's any additional tweaks or changes,
sending that over.
Okay.
Sounds good. I'm sending that file right now.
Okay. I will look forward to your email, and then we'll go ahead and get you the necessary information.
Yeah. Thank you, and we'll move forward from here.
All right. Sounds good. If you would like to give me a moment here, I can have you talk to my manager, who would be able to do a quick